students. Today I'll go with physics session. Clear? In my previous videos, most of the topics we have covered. The power and heating effect is left with, and I'll go with numericals in one session. Today I'll discuss power and heating effect. Come. Now, very important power. Last year in the chapter work, energy and power, you have studied power there also. What is power? Rate of doing work is called power. Any work when it is doing in a unit time, then it is known as power. Rate of doing electrical work is also called power. When I am talking about electrical consume, that is electrical energy is there. That is the power, the rate of doing or rate of consuming electrical work or electrical energy is called power, electrical power. Again one word, rate of doing electrical work is known as power. Rate means I am talking about time. So power is equal to work upon T, that is W upon T. And we also know that what is relationship between work and energy, that is ability to do work is called energy. So here ability to do electrical work or the energy consumed in 1 second or in unit time, then it is known as E upon T. We'll represent it by the electrical energy consumed by E and small t. So power, now what is the unit of work or energy? That means joule. Joule upon time second. Joule per second, or one word, that is watt. Watt is the unit of power. What is 1 watt? It is the amount of energy consumed, amount of electrical energy consumed in 1 second is known as 1 watt. If we are talking about bigger unit, then 1 kilowatt is equal to 1000 watt. Clear, students? So this is power, very easy. The rate of energy consumed or the rate of electrical energy consumed is known as power. Rate means I am talking about time. Clear? Now will come how the power can be related to volt, current and resistance. That is, we relate with Ohm's law. Volt, current and resistance. How? Now there will be 3 formulas could be possible for power. That is, if in terms of V and I, in terms of VNR and in terms of current and resistance. First, when the power is in terms of volt and current. Volt and current, that means how much amount of work done and the current is there, flow is there. If I say V is equal to W upon Q, already we are familiar with this formula. In potential difference, I told you that amount of work to carry the charge from one point to another is known as potential difference. So V is equal to W upon Q. We know that Q is equal to I into T. So W is equal to V into Q. Or we can also call, if Q is equal to I into T, then W is equal to V into I into T. And if I put this formula in P is equal to W upon 2 T, instead of W I am writing VIT upon T, that is W upon T. So T cancel, we get the relationship between power, potential difference and current. Simple. Again I am repeating, when the power in terms of voltage and current, we know that potential difference is equal to W upon Q. So by current we can frame this formula, Q is equal to I into T. Current is equal to Q upon T. So Q is equal to I into T. And W is equal to V into Q. If these variables are there in the numerical, you can use directly, that is V and Q, you can find work done. And we know that Q is equal to IT, so V into I into T. And in the formula of power, P is equal to W upon T. So instead of writing W, I can write this VIT over here. Upon T cancel, we get this relationship, that is power in terms of potential difference and current. If in the numerical they are asking power, these 2 variables will be given. Right? Now, if it is in the terms of volt and resistance. Now, P is equal to VI, we got from here. Now, by Ohm's law, we know that I is equal to V upon R. Because we want to get the relationship between V and R, nothing to do with this current. So we'll remove this current. By Ohm's law we can use this. Instead of current we can write V by R by Ohm's law. So P is equal to VI. Instead of I am writing here V upon R. So V square upon R. This is the relationship between the potential difference, resistance and power. This is how you can frame. These can come at 2 marks in your board exam. Get the relationship like this. Next is power in terms of current and resistance. Here no need of voltage. Now in P is equal to VI we have to remove this. So P is equal to VI. This is already we got here. Now by Ohm's law we know that V is equal to I into R. So we have to remove volt. So instead of volt I can write IR into I here. This is V. Instead of V we can write IR into I. So P is equal to I square R. This is again the relationship between the resistance and the current. I square R. So these are the formulas. P is equal to VI, P is equal to V square upon R, P is equal to I square R. These are the 3 relationships we can get in power. So this is how the power is defined. Now next come very important heating effect. How the electricity is converting into heat. This is very important. Now suppose if I take any gadget, I am taking here one gadget here, or any resistance. Every gadget has their own resistance. So the wire has its own resistance. If I take some high resistance wire, suppose if I am taking nichrome wire has high resistance. This is battery. This is battery switch, ammeter and voltmeter, which is always connected in parallel, and this is the current flowing. Clear? High resistance battery means high resistance wire means opposing the current quite high. Now how it get converted into heat? What is the relation between current and heat? See, when the current starts from here means charge is flowing. Charge is flowing and here we have taken a very high resistance wire. So hindrances are more. When more is the hindrance, this charge tries to flow out from here to this position. And the hindrances are quite high. So that time what happened? The electrons are moving very fast and they are colliding with each other, releasing the energy. Because of the hindrances, the current is not able to go properly, and what happens? It tries to overcome this resistance. So when it is trying to overcome, the electron which is present here in this resistance wire will move faster and the collision of these particles will start, or the electrons will start. That what creates energy. That energy is converting the energy which is releasing here by the collision of electrons will get converted into heat. Heat energy. When you're rubbing your hand, you can see the hands become a little warmer. So here collision is there, and why the collision? Because the current tries to overcome this high resistance. This is how the heat is generated. Right? So very important. So nichrome is a wire which is very high resistance. Most of the gadgets are those which are giving us heat, like geyser, electric heater, iron, electric iron. Those are having nichrome wire in it, which tries to resist the current, hindrances. Okay? So more the coil like this is the nichrome wire. So what happened? The hindrances are more. Right? So this is how the heat is generated. Simple. So what is heating effect? When the electrical energy is converting into heat energy, which we can see. Suppose you are putting the charger for a longer time, and what you see, the charger becomes a little hot. Switch becomes a little hot. Right? Geyser, the water is heating. Iron, that is heating, and we are using it. These are the applications. These are the appliances which we are using. Clear? Now, next is, this is gadget. This is the voltmeter. This is the connectivity. Voltmeter is in parallel to the resistance and ammeter is to measure the current. Now if I relate this, what is the formula comes? See, if energy is converting into heat energy, just now I told you that heat energy, that is energy is converting into heat energy. Electrical energy, I am talking about electrical energy. Now we know that P is equal to work upon time. So here work is converting into energy, that is energy upon time, or we can say H upon T. Electrical energy is converting into heat energy. So H is equal to P into T. If P is equal to VI, just now we have framed this equation. So if P is equal to VI, then instead of P we can write VIT. Right, students? See, very easy. And we know that IT is equal to Q. So V into Q. This is one formula of heat energy. If the potential difference is there and the charge is there, we can find amount of heat consumed. Okay? Released. Now by Ohm's law we know that V is equal to IR. Putting this instead of V here, I can write IR by Ohm's law. So IR and Q is equal to I into T. So VQ instead of VQ I have written IR, Q, I into T. So I square RT. This is the formula for heating, that is H is equal to I square RT, which is known as, yes student, anyone? Which is known as Joule's law of heating. Joule's law of heating. So what is Joule's law? What Joule's law says? That heat is directly proportional to the square of the current. Heat is directly proportional to square of the current. Heat is directly proportional to resistance of the conductor. Heat is directly proportional to the time taken. More the time is taken, more amount of heat is released. If you are putting your charger for a longer time, 1 or 2 hours, suppose your laptop is charging, you can see the heat is there. So this is how we can frame H is equal to I square RT. For how many hours, for how many days, that I'll discuss in the numerical portion. Okay, how to find? This is only to find the heat. So if I say H is equal to I square RT, this is Joule's law of heating and formula for heat to find the value for the heat. Clear? Okay. So this is how the chapter is closed. Next session I'll continue with all the formulas related to this chapter and we'll go with numericals one by one. That will take time. That is, I'm not taking here. Numerical portion, definitely I'll go with all this. Okay. So please like, share and subscribe my channel. Thank you so much, students. Thank you.